Alright, this is the video for the Algebra 2 Unit 8 study guide. I'm just going to work through some of these problems for y'all. The first one that we have here is just using this formula that you're given, putting all the inputs in the right place. So it says uranium-238 is a radioactive substance that decays 50% every 13 years. How much of a 12-gram sample will exist after 52 years? Alright, so just so we are clear, the AO, which is the amount at the beginning, or A0 actually, is that there is 12 grams. The E is a mathematical constant that we're going to do on the calculator. K is 50% or 0.50, and T is equal to the number of years that we have divided by the number of years that we told it decays 50% every year, every 13 years. So it's called the half-life. When we divide those, we get 4. So then we're going to take all that information and we'll put it in the formula. So then A will equal, or the amount that we have after 52 years will equal 12 times E raised to the negative 0.5 times 4. So over here, let's get a calculator open. We'll just use the scientific calculator today. We're going to type in all these values. 12 times E raised to the negative 0.5 times 4. So we can see we have 1.62. I think it says to round to 3 decimal places. So 1.624 is how many grams there will be at the end of the 52-year period. So that's that first problem right there. Moving on. This is asking about how the function changes when you change a certain part of the equation. There's really two main things here. You either have a horizontal or a vertical shift. Vertical shifts are going to be like B. So this is going to be a vertical shift. And then C and D are going to be horizontal shifts. I'll actually start with B. B is a shift of 2 up, because plus 2 is going to be up 2. If there was a minus or a negative 2 here, it would be down 2. But since it's a positive 2, it's up 2. Now with the horizontal shift, it's a little bit different. If there's a minus a number, that's going to be a shift to the right, and a plus a number is going to be a shift to the left. So this one's going to be right 3, and then this bottom one's going to be left 9. That's pretty much it. So you just need to know what those numbers and those different positions, how they shift. Those are the main two that you need to know. Up and down is going to come where it's added at the beginning of the equation, and left and right is going to be inside the parentheses here. Okay. So another formula problem. Let's talk through all the different values. A is what we're looking for. We're looking for how much he has at the end of 10 years. The initial amount, 8,000, is the P value. The R value is the rate in a decimal form. So this is going to be 4% is going to be 0.04. So again, this is P, this is R. T is going to be the number of years, and N is the number of times per year. This says monthly. That's why we're going to use 12 for our N value. So we go over here and we plug everything in. We do A equals 8,000, 1 plus R divided by N, so 0.04 divided by 12, all raised to the N times T power, so that's 12 times 10. And then from there, we're just going to go plug everything in. So we have 8,000 times 1 plus 0.04 divided by 12, close the parentheses, raised to the n times t power. So you can see we got 11,926 and 66 cents. 11,926 and 66 cents. That is the final amount that he has. Sorry, my dollar sign looks a little weird. You get the idea. All right, pretty straightforward. So just plugging everything in, make sure you understand what each of the parameters are, plug it all in, do it in the calculator. Okay, the next two problems are just pretty much filling in a formula. You're just going to use your calculator for all this. So for instance, what it's telling you to do is to take the x values and to plug them in here and get all of the answers that you would get. So I'm going to do 2.3 raised to, and then I'm going to do each of those ones as a exponent. Raised to the 0 power is 1. Raised to the first power is 2.3. Raised to the second power is 5.29. Raised to the negative 1 power is 0.43. And raised to the negative 2 power is 0.19. I'll round that. The next column, you're just combining all of that into a point. So this is going to be a point that's going to be 0, 1, 1, 2.3, 2, 5.29, negative 1, 0.43, negative 2, 0.19. And then the inverse is you just flip them. So we're going to flip each of those points, and it's going to be 1, 0, 2, 2.31, 5.29, 2, 0.43, negative 1, and 0.19, negative 2. That's all you're doing. So again, you plug in the original value, and for the x, you get the answer. For the fx, you put those two together as a point, and then you switch those points to find the inverse. Logarithm tables are pretty straightforward. To understand what's happening here, you have to think in reverse in terms of exponents. So what this is really asking me is 5. The reason I'm using 5 is because that is the base of my logarithm. It says it right here. So 5 to what power gives me 1? That's this number in the x. 5 to what power gives me 5? Sorry. 5 to what power gives me 25? 5 to what power gives me 1 over 5? And 5 to what power gives me 1 over 25? Most of this is pretty straightforward. We know the rules about exponents tell us that any number raised to the 0 power is 1. 5 to the first power is itself. 5 squared is 25. And then these are, if you'll notice, there's a connection between these pairs, that 1 over 5 is going to be negative 1. And 1 over 25 is going to be negative 2. It's the negative version of the number that it was when it was that number instead of 1 over that number. So if 25 is squared, then 1 over 25 is negative squared. And that's pretty much all you're doing on that. Lastly, we have these logarithm rules. Pretty straightforward. You're given a logarithm value right here, And notice the difference between the two logarithms is that the 3 and the 8 have been switched. This is called the change of base. You have a formula chart for this that you can use on the test that has all these formulas. But the change of base formula says that in order to switch those two numbers, all you do is do 1 over the original. So I'm literally going to come over here and do 1 over 0.2418. Was that right? The right number? Yeah, 0.2418. And I get 4.14. We'll round it. 4.14. Actually, we'll do 4 places since we were given it in 4 places. 1, 3, 5, 6. Sorry, let me get back. 1, 3, 5, 6, because that is 1 divided by the original value. The next one, we're looking at numbers where they have the same base, both have a base of c. And when you do this, you need to understand how did they get 3 from 12 and 4. And the way they got it is they did 12 divided by 4 gives us 3. So when that happens, the logarithm rules tells us that we can just simply subtract 0.7233 minus the one we're dividing by, 0.4590, and that will give me the logarithm of 3. So let's see what that is. So the log c of 3 is whatever 0.7233 minus 0.4590, and it's 0.2643. So the understanding here is that the rules of logarithms are like the rules of exponents. So because these numbers were divided to make 3, we subtract the logarithms to find the new answer. And to switch the bases like we did in number 6, we just do 1 divided by that number. You'll have different problems on the test, so you'll just have to know those rules and you'll have that sheet in front of you.